This video is going to be about the integral of the trigonometric functions. So first thing we have to remind is the derivative of the trigonometric functions. So these are the formulas for the derivative of the trigonometric functions. The derivative of sine of u is equals to cosine of u times the derivative of u. The derivative of cosine is negative sine of u times the derivative of u. The derivative of tangent is secant square of u times the derivative of u. The derivative of cotangent is negative cosecant square of u times the derivative of u. And the derivative of secant is secant times tangent times the derivative of u. And finally, the derivative of cosecant of u, which is negative cosecant of u times cotangent of u, times the derivative of u with respect of x. If you don't know these formulas, remember that you have to learn them because those are the formulas that are going to be useful in order to verify our integrals. And these are the formulas for the integral of the 6 trigonometric functions. I will ask you to stop the video now and rewrite the 6 formulas on your index card and learn them. You have to learn them by heart, otherwise it will be impossible to integrate those functions. So please stop the video now, and once you have rewrite the formulas, you can continue. Okay, let's start with our first integral, which is the integral of sine of 4x times dx. So in this case, as we are talking about sine of u, my 4x is going to be my u. So let's make u equals 4x. If u is equals to 4x, then du will be equals to 4 times the x, but as we don't have 4 times the x, we only have dx, we're going to divide du over 4. So du over 4 will be equals to dx. So this will be the integral of sine of u, making the change of variable, times du over 4. We write the constant out of the integral sign, 1 over 4 times the integral of sine of u times du. And looking in your formula, you know that the integral of sine of u, it is negative cosine of u plus c. So this will be negative 1 over 4 times cosine of u, which is 4x plus c. And that is our primitive function, antiderivative, or indefinite integral. Let's do the verifying. Y equals negative 1 over 4 cosine of 4x plus c. Dy over dx, which is the derivative, will be the constant times the derivative of the function sine of 4x times the derivative of the argument, which is 4, plus 0, which is the derivative of c. So this will be 4 and 4, negative and negative. The y will be equals to sine of 4x times dx, which is exactly the first integrand that we have at the beginning. I am doing the exercises that you have on your notes. So if you want to copy the exercises step by step using this video, you can do it on your page 25. Page 25 on your notes. It is it is when you can find these exercises. The second exercise is the integral of t squared times sine of t cubed. So in this case, what is going to be my u is t cubed. So if we make u equals to t cubed, du will be equals to 3t squared times dt. And as we don't have 3, we have to divide du over 3, which be equals to t squared times dt. As you can see, we use substitution rule to obtain the integrals of these expressions. So this will be the integral of sine of u times du over 3. Again, constant out of the integral sign, we have 1/3 of sine of u times du, and that will be 1/3 of negative cosine of u plus c. And substituting back and multiplying the constant times the negative sign, it will be negative 1/3 of cosine of t cubed plus c. So here you have our original function, our antiderivative, or our indefinite integral. Negative 1/3 cosine of t cubed plus c. Let's do the verifying. If the function is y equals to negative 1/3, the derivative of that will be the constant 1/3 times the derivative of cosine, which is negative sine of t cubed, times the derivative of the argument, which will be 3t squared, plus 0, which is the derivative of a constant. So dy will be 3 and 3, minus and minus, it will be t squared times sine of t cubed times dt in this case. And I'm sorry, this is the derivative of y with respect of t, because the variable of integration is not x but t. Our next exercise, we have the integral of the square root of x times cosine of x to the 3/2. So again, we need to find out u, and u is going to be x to the 3/2. If u is x to the 3/2, the u will be 3/2 of x to the 1/2 times the x. And as we have only x to the 1/2 times the x, we are going to multiply the u by 2/3. So 2/3 du will be equals to the square root of x times dx. So rewriting the function with a different variable, we will have the integral of cosine of u times 2/3 of du. So you write the constant out of the integral sign, and so you have 2/3 times the cosine, the integral of cosine of u times du. And by using or knowing the formulas, you know that the integral of cosine is sine of u plus c. So substituting back, we will have that y, or the antiderivative, it is going to be 2/3 of sine of x to the 3/2 plus c. And that's your original function, or your indefinite integral. The function, as it is mandatory to write it, will be 2/3 of sine of square root of x cubed plus c. Let's do the verifying. The verifying will be the derivative of y with respect of x will be 2/3 of the derivative of sine, which is cosine to the 3/2, times the derivative of x to the 3/2, which is 3/2 of x to the 1/2 plus 0, because the derivative of a constant is 0. So by simplifying this, we'll have 2 and 2, 3 and 3, which will have the square root of x times cosine of x to the 3/2 plus 0 times the x, or square root of x times cosine of a square root of x cubed times the x, which I think is the original function. Finally, on exercise number 5, we have a product, and it is the integral of the product of cosine to the n of ax times sine of ax times dx. So in this case, we cannot make u the argument, because if we make u the argument, which will be ax, du will be a times dx, and we have another thing besides a to dx. So this is not possible. We have to look for a different u. And in this case, I'm going to make u cosine of ax. So if I make u cosine of ax, the derivative of u will be negative sine of ax times the derivative of ax, which is a, times dx. So now I have something very, very similar to what I have on my original function, as you can see. but I have to divide du over negative a, so I have now sine of ax times dx, which is the exact other part that we have. So this will be the integral of u to the n times negative du over a. And if you think that a is a constant, you can write the constant out of the integral sign. So you have negative 1 over a times the integral of u to the n times du, and using the basic rules, you have to the integral, you know that the integral of u to the n is u to the n plus 1 over n plus 1 plus c. So substituting back, you will have negative 1 over a times u, which is cosine to the n plus 1 of ax over n plus 1 plus c.